All right, welcome everybody. Thank you for attending this breakout session. This is our first breakouts of the day following our plenary. And I just want to take a moment to welcome all of you and welcome our guest speakers today. We have a great lineup and I'm super excited about the conversation that they're going to have and all the information that they're going to share with us. So this session, you are in the right place. It's UAS applications in the utility sector, and it's about saving time, money, and lives. And there's just a whole bunch of great information that I know we're going to get from our speakers today. Our moderator today is Matt Dunlevy. He's the president and CEO of SkySkopes. And with that, Matt, I will turn it over to you and let you introduce our other panelists today. And I just, again, welcome and thank you so much for being here.
Absolutely. Thank you very much, Amanda, for the introduction. As advertised, I'm Matt Dunlevy, and I am the CEO of SkySkopes. I would echo what Amanda said about our panel here today. We really do have a murderer's row of UAS subject matter experts. I'm getting a little bit of deja vu myself, because I know it wasn't that long ago when there was a webinar that the UASCI put on that I was doing another one of these webinars with you. And I really think, just got to give a shout out to UASCI and Amanda and Harv for the great work that they do, and particularly for the the UAS Tech Forum. I've been coming to this conference for several years now and speaking at it. Kind of sad that we have to do it over video chat, but that is something rather than nothing. That's kind of the sentiment in some of the use cases that we have in UAS too. And especially that UASCI is working so closely with Oklahoma and Kansas. The state of Kansas in particular, I know, has just an outstanding UAS ecosystem. And we have a phenomenal panel today. We've got Eric Bitzko, who is the system maintenance supervisor for Pedernales. I hope I said that correctly, Eric. Electric Cooperative in Texas. They are one of the most well-known co-ops as far as UAS adoption goes. And then we've got Mr. Will Lovett from Phoenix Air Unmanned. He is the managing director and just a well-known heavyweight slugger in the UAS drone services world, in the services world. And we also have Mr. Mike Kelly from Evergy. He is the senior UAS coordinator. And Evergy is also making some real waves as far as their progressive mindset around unmanned aircraft systems and their incorporation in the world of those bigger IOUs or investor-owned utilities. But, industries across the board, we're seeing the value of unmanned aircraft systems and how they can be incorporated into their business models. I'm seeing a lot of, some chat going on in the boxes. In the chat box here. So I want to encourage everyone, if you have any questions throughout this panel, we've got 50 minutes. Do please put them out there and I'll do my best to get to them. But otherwise, without further ado, let's get down to business. And I have my first question is going to be to Mr. Eric Bitzko, because I'm with a drone service provider as well. And, one of the toughest nuts to crack, I think, in drone services is those rural electric co-ops. So anytime we can get a subject matter expert, and especially someone like Eric, who's the system maintenance supervisor and an experienced drone pilot and professional, on the hook, so to speak, to kind of divulge a little bit about what they've got going on, I really think that's good for the industry as a whole. So, Mr. Bitzko, what value do co-ops see in the incorporation of unmanned aircraft systems into their workflow, and particularly the co-op side? So, why did Pedernales get into drones? And what is the value statement that they saw, and how has that changed, good sir?
So we've been kind of all over the place. The biggest difference and the biggest focus for the co-op side of the utility sector is we're not for profit. So every dollar we make, we give back to the membership and capital credits at the end of the year. Typically that equals about a free December electric bill. So in order to cut costs and kind of do it as efficiently as possible and benefit the membership the best we can, we started looking into some drone technology back in 2015. And we started off with storm response. That was kind of the easiest one. We had some 500-year floods come through, and we ended up tying a pull line to the drone and flying it across a couple flooded rivers. That was the kind of the origin story. We then kind of shifted gears and started focusing on day-to-day operations and how we can improve certain workflows, and especially from a maintenance avenue. Where we've seen the biggest ROI and the biggest bang for your buck is on system reliability. We've taken our reliability from, over 100 minutes of SAIDI time all the way down to about 40 minutes of SAIDI time by implementing drones into that inspection workflow and streamlining the maintenance on our system. That's really been where we've kind of doubled down over the past few years. We've changed approaches a couple times throughout the year, and I think that's going to continue to change as we continue to scale the program. But for us, coming from the co-op side, the reliability has really been the biggest ROI for us in implementing the drone technology.
Absolutely, and thanks, Eric. Just for people who are unaware, could you tell us what is SAIDI? You mentioned something about SAIDI there.
So SAIDI is a reliability metric. It stands for System Average Interruption Duration Index. So it pretty much takes the average outage time per meter and gives you a metric that you can then measure reliability for a system. And you can break it down system-wide or co-op-wide. You can break it down by district, by feeder, by substation, and it gives you a lot of flexibility there to give you good insights into the reliability that you're actually seeing on your system.
Thanks for that. And yeah, that's a great answer. I really enjoy hearing from co-ops when it comes to the adoption of unmanned aircraft systems and especially what use cases you see within your own organization. So let's move on to our next distinguished gentleman on the panel today. So we've also got Mr. Will Lovett again from Phoenix Air Unmanned, or POW is the acronym there. And just from the outside looking in to some of the things that Phoenix Air Unmanned has going on, it's really impressive, and it's making national waves because they are really getting the job done when it comes to beyond visual line of sight. And beyond visual line of sight, we've got the BVLOS acronym. That's really the quote holy grail. It's kind of cliche to call it the holy grail. I like to say that beyond visual line of sight are the 5 golden words of the world of drones, and few organizations are getting it done as well as Phoenix Air. So over to Will, just a quick question for you. What hurdles did you have to get over in order to get going with BVLOS at scale the way you're doing, potentially better than anyone?
Well, great question, and thanks for the group for having me to speak to that. Phoenix Air is a 5-year-old company. We're a services provider, and when we decided to stand up this division, certainly the program was set up to be a premier operator. Safety is paramount, and we looked at several different segments of where we could use UAS to save time, to save lives, and save money, and we were led to the utility industry. And the first hurdle we had was regulatory enablement. How do we get legal to fly BVLOS? And we were very fortunate to meet up and work with Xcel Energy about 4.5 years ago, and we've been growing and doing work for that utility ever since. It is a very evolving process with the FAA, as everybody that has submitted waivers and requested for exemptions understands. The rules are changing, the aircraft are changing, and we try to stay one step ahead of what's expected of us and what is the best thing to do for our operations and for the industry. Every year that we have accomplished flying over transmission lines, I think as we are approaching about 6,000 total miles this year, which spans over the last 3.5 years of flying. And not all those are BB There's around 2,500 of those are BB but still quite an accomplishment. Proud of our team for getting us there and getting us there safely. But every year we learn something new. We amend, we change our procedures. Of course, we go back to the regulators and ask if we can have modifications and show them why and show them the data. So it's very much a program where we're trying to get better and safer and provide the client the actionable intelligence that they can do their jobs better and not put lives at risk with either people in helicopters doing inspections or on the ground. It is becoming more efficient. The aircraft are allowing us to integrate more payloads. So ultimately, we'd like to get to an aircraft that can fly with multiple payloads. So you only have to do the flyover once a year, and you can get either the LiDAR or the RGB or whatever it is that you want, and you don't have to expose the aircraft or other elements, more than once a year. Hopefully, we'll get to that. But again, this biggest hurdle is the regulations at this point.
Yeah, and I can definitely, I've felt the burn on the regulatory side too, and it's not just with BB and we're in a heavily regulated industry, and so here's a question for you, Will. It's difficult to qualify, I think, how UAS and also especially BB UAS are going to save lives, but to people like us, it's apparent that they do, and also with BB they can. So do you think that the value proposition with BB at least as we know it today, do you think it's more about saving time, or do you think it's more about saving money?
Well, ultimately, it will save money. But again, if you look at the combination of all that's put out to do a BB operations with the people, the equipment, the sensors, the investment, and the regulatory enablement, obviously we are moving toward it being cost effective. But at this point, we're all making investments to get there. And I believe we're, again, making improvements every year, but it's not quite there yet. The saving lives piece, that speaks for itself. And I don't think anybody should risk their life to take an image of a utility asset, but I understand it's important and it has to be done. And for the masses, this seems like an alternate approach that one day will be much cheaper than the current method.
Yeah, and I would agree with that. I would say that for the end users that organizations like ours have, and they're mandated to get a lot of these inspections done, it's going to save them money. And BB at scale and in a tried and true regulatory enabled environment for it, I think is going to save organizations like ours the time. So instead of having to launch and then stay in the air until your battery runs out on a multi-rotor, and then land and then swap the batteries, and that takes a lot of time to get back up and then drive to another location. Whereas if you're flying BB you can stay up in the air almost all day. So it saves the drone providers time, and I think it ultimately will be more economical for the end users. But absolutely, I would agree with you on that one, Will. I'm not saying that I saved the best for last year just on this initial round of questions, but we've got kind of a representative of the meat of the UAS industry right now, which, I mean, I've been in this for almost a decade. Will's been around for a while as well, I know. And I still think, especially with the laws as they are and the technologies as they are, it's a fledgling industry. And when we have a representative of a UAS program in a major IOU, Will mentioned Xcel Energy, and Mr. Mike Kelly is the senior UAS coordinator at Evergy. We really get to hear kind of what the state of the industry is, because they are really the meat especially in the pandemic. you know, where you see some of the oil and gas companies slow down what they're doing with unmanned aircraft, you still got almost full speed ahead with a lot of the big investor-owned utilities. So just a broad question for Mr. Kelly, you know, knowing that Evergy is really gaining some significantly positive attention nationwide for what you guys are doing with unmanned, could you give us a little bit of insight into, you know, as an IOU, what are you guys doing with unmanned aircraft? And, you know, what would you say how do you define the value of unmanned aircraft to your investor-owned utility?
Yeah, so, you know, a lot of what we do is really what the theme of this session is saving time, money, and lives. So, you know, we do a little bit of everything from, you know, visual inspections on our transmission and distribution assets, substation, our generation assets. We actually, you know, that's both outside and inside the plants themselves. So inside the plants, you know, in the boilers and the ductwork and the stacks, we've got specialized units that have cages around them. A lot of people know, you know, the Elios units. We use those pretty frequently in our fossil fuel plants, really any confined space area. We'll use that almost as a preliminary inspection tool. So, you know, that's a big one there that saves time. You know, we can send that in before it's man safe, as we would call it, you know, getting all your permits and everything. And so saves time there, saves money. It's a lot cheaper than setting up, you know, spending time and money setting up scaffolding and all of those resources. And then also it saves lives. So we're not sending a person in to, you know, what could potentially be a very dangerous environment. So we'll send the drone in first to check out what's going on, get a better idea, and then decide if we then need to send an individual in to complete that inspection if we weren't able to with the drone. So that's a big one that goes right with the theme of the session. We also have been doing a lot around the photogrammetry operations. So, you know, saving time and money there is a big thing with our design folks, our engineers. So we can bring in all of this data that, you know, wasn't necessarily available. Satellite imagery can be, you know, especially in our rural areas, pretty grainy at best. You know, you can't really design on top of that. So bringing in the imagery, the elevation data, you know, our pre-existing survey data, we can tie all that together and get our designers and engineers to start designing in what we call real space. So, you know, we're able to get down to centimeter level accuracy with a lot of those models. And it's really dependent on project to project what level of accuracy we need. And we also participate in some of the industry, you know, industry-wide events as far as like integration pilot program and things like that. So we've been a leading role in the Kansas integration pilot program with KDOT, K-State, IRIS, and others to really try and, you know, our focus was really try and improve the concept of using solely onboard detect and avoid technology to enable scalable beyond visual line of sight operations. You know, through that, I think we kind of came to a determination that it may be a hybrid model, maybe, you know, use on board, but also with some form of ground-based detect and avoid technology. And like Joe had mentioned earlier today, you know, in the keynote session, that next step is what we're really excited about, you know, what's happening after the first iteration of IPP. So excited to, you know, see what that's all about and really just try and progress the industry as much as we can. So, you know, Evergy, we're not, we don't have, you know, 50 to 100, you know, just drone pilots throughout everywhere. We kind of are taking that hybrid approach of having an internal group, you know, not a huge group, but a group of pilots that are certified and able to operate, you know, for those smaller scale projects, and then a group that handles the bigger, you know, projects, more advanced stuff like photogrammetry, potentially LiDAR, beyond visual line of sight, and then, you know, also utilizing contracted services from third parties for those large scale, you know, kind of system-wide inspections that we see coming in the future. So, yeah, from a high level, that's kind of where Evergy stands, and we're, you know, a lot of the larger investor-owned utilities are as well. So, so yeah, that's kind of at a high level of where we are at.
Absolutely. Thank you very much, Mike. And we did actually have a question come in. So I've got something to throw out to Mike and to Eric here, just as you guys are, you know, the end users working at the utilities and different ones. So hopefully maybe a different perspective too. But, you know, some utilities have had, so to speak, false starts when they're trying to make their own drone programs internally. One term that I've heard in the past that I really like is called a tiger team. So if you've got your own pilots in house, you know, you've got those tiger teams. You know, what advice would you give to a utility that is looking to get a drone program started? Because there are so many still that need to and will. And then what advice would you give them to, once they have it there, how do they scale?
Yeah, you know, some advice I would give is, you know, and I think this is pretty common throughout what you would hear from anyone that's kind of got a established program in place, but start small. You know, there's no reason to go after beyond visual line of sight right away, or, you know, some of these larger projects. Start small, think of what you can get that immediate return on investment right away. So, and another thing is, you know, kind of rolling all that up into one thing is go after that low hanging fruit. So for us, you know, just for example, for us, it was out on the transmission lines. You know, they're out in the middle of nowhere, they're large, easy to detect. You know, since they're larger structures, you can see those issues a lot easier because they're probably going to be large as well. You know, don't focus on those hairline cracks on an insulator at first. Look for things that are going to cause an outage right away. Storm response, like Eric had said earlier, that's a good one to do as well. So, you know, my advice would be, don't, you know, bite off more than you can chew. Start small, go after that low hanging fruit.
Yeah, and I'll just reiterate what Mike said. I mean, he nailed it right on the head. You know, pick a beachhead and take that beachhead first. You know, for us and for the folks that I've talked to, the other co-ops that I've kind of, you know, helped kind of explain how we got started and where they should start. You know, starting with a small airframe like a Mavic size frame or something like that. You don't need to go out and buy a 200 or 300 series drone. You know, get one or two pilots trained up, get those champions identified early on that are interested in the technology and want to do it, and then let them surround them with some subject matter guys. You know, get a couple linemen, a couple engineers, get some GIS guys in there, and start working to build that team out. You know, if you focus on something small and eat that elephant one bite at a time, you know, that's going to lead to those small successes and that snowball effect as you roll down the hill. When, you know, like Mike said, when you start looking for discrepancies out on the line, you know, don't look for, you know, the small ones. Look for just the ones that jump out. You know, broken's broken. The great thing about electricity is when it fails in a pretty spectacular fashion. So, you know, it's easy to find those blatantly obvious discrepancies, even if they don't have that lineman background. So start there, start small, and then as those wins start building, you get that momentum, and then you can start expanding it out and scaling it to different, I guess, inspectable items, and you know, go to, you know, okay, failing equipment, or, you know, we know that from the standards committee that this equipment's been giving us problem in the past. Let's proactively change it out. Let's upgrade legacy framing. Let's start incorporating more and more and more and more. As you get that workflow kind of really fine-tuned and honed in, that's when you can start stacking inspectable items onto that.
Absolutely, and thank you for that, gentlemen. So, you know, that makes me think about another crucial factor in getting a drone program going, you know, within a utility, and that is the quintessential question that's plaguing almost everybody in the industry right now. And you know, Mike, earlier you mentioned the Helios airframe, and so Do you guys, and I think this is good contrast between the two REC, the REC and the IOU, and Mr. Lovett, please feel free to chime in, because we know that you've got a lot of experience with different airframes too. But if a co-op is starting a drone program, what is the airframe that's going to be most likely the first one that they choose? I'm sorry, not just a co-op, or any utility.
Well, I'll start. You know, we started off with too big of an airframe. We had an H920 that kind of kicked off the program, and that was a pretty steep learning curve to go from a lineman where, you know, bigger hammer is the answer, to flying a drone that's a pretty good size aircraft. So I would say, you know, lean towards the Mavics, the Autels, the Antifis, the Golden Eagles, those smaller platforms that, you know, are I don't want to say cheaper, but are less expensive, to where you can get some good understanding and familiarity with the platform, and then scale up from there as that skill builds. You know, once you get, you know, 100, 200 hours on that smaller platform, it's less intimidating going over to a much larger platform like the 200 or 300 series style of drones, size of drones. That's my perspective. That's one of those, you know, hindsight's 2020. You know, that's what we train with, is those smaller style drones, to get them the experience, get them the familiarity with the controls, and then, you know, running them through the NIST course, and getting them able to position the aircraft and the camera to take good quality image sets to take back and review them.
Yep, I'd, you know, just kind of reiterate that. Start small, start with platforms that can do multiple things. So, you know, whether it is the Mavic, or even kind of one in between those, you know, M series, those 200, those 300s, as an Inspire. You know, that's what we started out with an Inspire 1, and it was able to do our visual inspections. We could do mapping with it. Would take great video and images for our corporate communications folks to push out, you know, those feel-good stories. So just kind of think of an airframe, you know, that's not going to break the bank, but also can do multiple different things. And, you know, that way you have kind of a Swiss Army knife of a drone, if you will. And then one thing I also wanted to mention about kind of starting is really get those policies and procedures and safety items in place as well. And that, you know, maybe something Will can speak on the, you know, they, you know, have the large scale with beyond visual line of sight, but, you know, even for just your small scale, going out, checking a line, checking a couple poles here and there, you got to have all of that stuff in place. Make sure, also data security, if you're using, you know, Chinese manufactured drones, there's just a whole lot that goes into that. So having those policies and procedures, your standard operating procedures, and other documents in place at the start is just going to make it go so much smoother. And that gets a lot of buyout from, you know, leadership as well, because you have a well-rounded program in place.
I was going to offer up some more, I guess, lessons learned and some advice to those similar to your comment, Eric, about the, you know, the aircraft that maybe was too big. I think it's really important not to try and force a owned aircraft to fly a mission that it wasn't initially intended. In other words, you make an investment on an aircraft and you want to go fly this camera for that mission, and then 6 months later you say, hey, we got another mission, let's do this camera. Yeah, you know, there's something that just wouldn't quite fit, but you have the asset you want to try. Not recommended at all. You know, there are certain platforms that you can buy and you can integrate different payloads, but some you can't, and some have autopilot, you know, integration issues, a little more complicated than the other. You know, the fit and form, all of those things are very important, but definitely you don't want to try to force an aircraft into a mission that, you know, it's probably not capable for.
Absolutely, and wisdom from all on that one. We did have a question that came in just now, and I wasn't expecting this one, but of course this is absolutely in line with the with the theme of this panel. And so when we're talking about saving time, money, and lives and utilities, you know, the missions are one thing, but you've got the data side, how you either pre-plan the missions or how you are able to take that data and turn it into a deliverable or actionable intelligence. And so this is a question to the entire panel here. So what advice do you UAS subject matter experts have to undergraduate students that are studying GIS?
I don't, to be honest with you. I have a lineman background, so I'm not even going to begin to get the line to y'all. So good luck,
Yeah.
Mike and Will.
Yeah. So we've done some photogrammetry, you know, we integrate into GIS and things like that. I guess advice, you know, if I could put myself in that position, I would try and get as much, you know, hands-on experience with, you know, integrating drone or UAS data, those photogrammetry, you know, those orthomosaics, those contour lines, those DSMs, all of those data sets into GIS or, you know, whatever data visualization application that you're using. You know, also going through the processing of that data. So using like a Pix4D, you know, simple one like Drone Deploy or Agisoft, you know, PhotoScan, using these, just getting that experience with those software packages on how to take the drone data, generate these orthomosaics, these, you know, data sets that you then transfer or integrate into GIS. You know, hands-on experience is what I learned best on. So I guess that's what I would recommend, is just getting some, as much as you can, get some hands-on experience with that data.
Yeah, I'll add to that, as the foundation of all the employees at Phoenix here, unmanned, are pilots, manned and unmanned, and some bring a level of experience with GIS and others don't. But everyone has a need for it. And so we do find that most people with a background of aviation got limited education on GIS. So we do a lot of OJT on that here. But to the point earlier from Mike, we spend weeks doing flight planning before we get to a site. In other words, we're flying, you know, hundreds of miles, and we don't want the flight crews out in the field trying to navigate populations, high density populations and airspace. We want all that to be completed and checked and verified before they get to the site, so that they are able to execute, and you don't have all those resources out there trying to, you know, get on a map and figure out what you can and can't fly. So absolutely, it's really important for us, and I can envision for anyone that's going to be in this environment, to be able to use that GIS data and understand, you know, where the aircraft can fly, what your limitations are, again, population counts, to add some different things, filters onto a map, and be able to understand that information to help you with flight planning. It does spend a lot of time, and again, it's one of those things, over 3 years, we're getting better and better at it and more efficient. Doesn't take quite as long, but it is important to do it here versus there.
Yeah, and flight planning is a great, you know, point on that. Geographical information that you can use to be able to help plan those flights. And another thing is, you know, even if there's still images that you collect out on the line, having a way to visualize those over, you know, your GIS layers is another thing that, you know, to start getting experience with. So even if you're not generating a large map with photogrammetry, you know, being able to automatically place your images over and tie to a specific asset in your GIS system or whatever system you're using is another great thing that I would say to look into and try and get as much experience as you can with. Because, you know, if you just have hundreds of thousands of images and you're thumbing through them through folders and things like that, it's not that efficient. So you need a way to visualize that data.
Yeah, and I'll reiterate with Mike. I mean, that was one thing that we kind of struggled with early on, was being able to take the thousands of images that you'll collect throughout an inspection and correlate it to a pole tag or a structure number, and kind of understand where in the world Carmen Sandiego is. You know, it's difficult from, you know, the back office when you're trying to review those images, and especially thousands and thousands and thousands. There's some good softwares out there that kind of help tie everything together and give that perspective that is absolutely needed when you're doing these detailed inspections.
Thank you. Yeah, and just as far as any advice I would have is on more of a qualitative side, is realize the value that you will have if you're a GIS professional going into the drone world, to the value stream, because it's integral to the flight planning and the deliverables. I'd say, you know, and the ratio of how many pilots to GIS technicians there are, it is so crucial to have GIS in your workflows. And in one sense, GIS is kind of a product too. But we have another question from the audience there about vegetation encroachment and human encroachment on the corridors. And, you know, I'll admit, at first I thought that might have been the most important reason to do overflights over transmission or distribution lines, was the vegetation management. So, and I know all three of you guys have had experience in this, so this is a question to the whole panel. What uses do UAS have in terms of encroachment on power lines?
So I'll kind of take a hack at this first. In the ink blot test, three things kind of came to mind to me instantly. You know, there's the regular EO imagery. Once you have experienced pilots and skilled pilots, you understand kind of the perception that you're looking through a fixed focal point, right? Where that sensor they get accustomed to. For us, at first, before we started doing the photogrammetry or, you know, started dipping our toe into LiDAR, we just did regular EO imagery, and you're able to kind of ascertain some perspective through different equipment on the pole. For us, you know, we're heavy distribution, so we know that that's an 8-foot cross arm up there. And if you're looking at, you know, 8 foot or 10 foot on either side of that line, or 15 foot from the top, you know, you can take a cross arm's width and measure out, you know, just visually and say, hey, is that encroaching into our aerial corridors? Again, double it and you've got top to bottom now. So that's how we started off getting our feet wet with looking for different encroachments on the system. And then, you know, of course, the photogrammetry and the LiDAR is pretty self-explanatory, but that was kind of one way that we kept the cost super low, to where we were at about 80 cents a span, as opposed to, you know, some of the higher costs with the more detailed data, right? It's vegetation, you know, you don't need that level of granularity a lot of times. So that's kind of how we started off for, you know, kind of balling on a budget, if you will. In identifying those different encroachment areas. And then of course, you know, you can scale to the photogrammetry, and then of course the LiDAR is the ticket for as detailed as you need to get.
Yeah, so kind of like Eric said, we, you know, we're still, you know, anything vegetation wise, we don't do a whole lot. We have our own, you know, the vegetation crew internally that does a really good job. Especially on transmission. Where we see a lot of the issues is more, like Eric said, on distribution. And so, you know, we'll use that drone as a visual inspection tool to try and, you know, see where we have encroachment issues. Our vegetation group and GIS is interested in the photogrammetry, the LiDAR applications. We're kind of looking into that, but another thing, I mean, you know, LiDAR is really probably going to be the key for that, just to be able to penetrate through the canopies, just a lot more detail than photogrammetry. You can do quite a bit of stuff with photogrammetry, but, you know, for the data they really want, I think LiDAR is probably going to kind of have to be the solution for that, you know, for that big data piece.
And one of the things that we kind of found is, as we kind of went down the rabbit hole, especially from the vegetation side, is we actually don't use drones anymore for our vegetation. We've kind of leaned more towards satellite imagery, and we partner with IBM Watson, using AI to kind of understand. And what we found was it was actually quite a bit more cheaper and a lot more efficient in using, I call them Russian satellites jokingly. I'm not sure what satellite imagery it is, but taking satellite screenshots regularly of our service territory and understanding growth patterns correlated with rainfall totals and kind of putting the pieces together there to where we can now apply thresholds to, need to trim yesterday, next week, next month, next quarter, and kind of start planning out a little bit more strategically with our Russian satellite imagery, as opposed to using a drone to fly those lines out.
Yeah, I was going to add to that. With we're trying to again provide another level of data to utilities, and I imagine every utility has their own method of inspecting and the camera and lensing specs. But right now with asset inspection, our focus is to get photos of the assets, but also a field of view wide enough to see the right of way, so you can actually see from that picture that you might have a problem, and obviously go back in LiDAR or get something a little more definitive. So at least you get something for change management as well as doing the asset inspection.
Yeah, and I agree with that, Will. And I think you guys are bringing up another question here, and not necessarily just in terms of linear infrastructure inspection, but I'm hearing LiDAR and I'm hearing photogrammetry thrown out there now. And we've already discussed a little bit about the airframe. So, I think my second to last question for this panel is going to be, okay, so I've heard that, the camera is just the electro-optical RGBs that we're putting on drones are someday going to be so sophisticated as to make, regardless of penetration, LiDAR obsolete. So my question is, do you see LiDAR, I think in vegetation management and right-of-ways, definitely is probably the superior sensor right now. But in terms of other use cases in utilities, like say substation inspection or even wildfire mitigation, do you see a difference in maybe and one having an advantage in other use cases in the utility sector between EO photogrammetry and LiDAR point clouds?
So I can kind of start on that. I can speak for what is available today, in the future as technology progresses. I'm not, theoretically, yes, as we get more and more data-rich sets from cameras, from just visual cameras, that could potentially be something that could make LiDAR obsolete. But as it stands today, if you're looking at just, land-based mapping, so for your coal piles, for your right-of-way, for things like that, photogrammetry is definitely the most cost-effective way to go. It can reliably map that, get you your elevation data, get you that visual imagery, multiple data sets from one flight. Now, where you start to get away from photogrammetry and into LiDAR is if you're trying to do, either structural analysis or sag analysis, sag tension analysis on your lines. So the conductor is just too small for photogrammetry to see reliably right now. And then you mentioned substations also, Matt. So, that's a lot of, it'd be a lot of fine detail that you have to get from that, environment. You have a lot of equipment that's really packed tight, closely together. You're really needing high accuracy distances. So LiDAR would definitely be the way to go there if you're trying to do inspections, take measurements. So, for those finer detailed inspections or projects, it's definitely has to be LiDAR, but for land-based, large-scale projects, photogrammetry is definitely the way to go, at least in our experience.
Thanks for that. Well, we are coming up on time here, and I always just have one, last question for panelists. Whenever I get to a panel, even if I'm just sitting on it, I want to answer this particular question because, I mean, it's just such an exciting industry, and things always take longer than we think. So they, like our gentlemen here say, start small, and it might be smart to go slow at first. But when we see the potential of drones, it's easy to get wide-eyed. And I like to really talk to the people who are in it day in and day out. Take a step back for a second and realize, look, I do this for a living. We do drones, and we live and breathe and sleep and eat drones. And sometimes you gotta savor that. But in order to continue to do so, you really gotta, and if it might just be speculation, think about what the future of UAS is. So I want to hear if our panelists are willing to talk about this. I don't want too much of the secret sauce, but guys, what do you see as the future of unmanned aircraft systems in the utility sector?
I'll take a hack at this. So that's a dynamic question, right? So I think, for us and for my perspective and what we've kind of seen over the past handful of years as we've kind of scaled is, you see certain patterns and trends, and I think that's going to continue to scale that way. I think, a couple key points there. I think that once programs get to scale, you're going to have the hybrid approach, kind of like, Mike and Will are part of. Right now we have an internal program, and that's 99% of the time. I think once we get to the point to where we really are at scale, we're going to need those third-party service providers to come in as kind of force augmentators, right? And force multipliers, if you will. I think that's going to be kind of key. But with that, once you get to the scale, and these companies that get to scale first, I think are going to have to double down on, once regulation gets eased up for us common folk to be able to fly a BVLOS, I think that's going to allow us to fly our system more often, to where instead of flying, a section of line once every 5 years, 3 years, 1 year, you're flying them once a week or once a day. And you have multiple platforms out there consistently flying and monitoring your system. And now that makes it a lot easier for AI to kind of digest that data more frequently. And it's more of a change detection problem as opposed to a anomaly detection program. So I think once we get to scale and the industry kind of starts merging, or all the technologies have those APIs built out, you'll have all these system inputs that are coming into your algorithms and analytic tools that are identifying not just drone data, but your SCADA system data, your AMI metering data, system telemetry that's coming to and from the field, and merging that with the drone technology and the drone data that's being collected. I think you're really going to start seeing that, the reliability metrics are going to be at the floor. Everybody knows that the world as a whole is becoming more and more reliable on electricity. And so by being able to identify not only just reliability on a day-to-day basis, but efficiency and, identifying those system losses and really being analytical about the system and what it's doing more or less real time, I think that's where you're going to see the industry in 3, 5, 10, 12 years is kind of more of a Skynet approach.
Thanks, Eric.
I definitely see the hybrid approach going forward. I look at it like in corporate aviation, many companies want to own a jet for whatever reason, corporate transportation, and others choose to charter. Some do both. Depends. Maybe you have an asset that only flies within the U.S. and you charter to go international. But I think there's a healthy approach for both at this point. Where we stand, I see, in the distribution business, it's really challenging for me as a service provider to send people out at a competitive rate to, that level of distribution line. You get in transmission, absolutely, that changes the dynamics quite a bit. And I think if you've got resources, employees, linemen that have the credentials and the training to do what's needed, absolutely, there's a reason that that's another tool that's available for a company to do that and do it safely. You get into more complex operations, not that a utility can't do BV loss, but there are things that the care and feeding of the equipment, both the ground vehicles, the aircraft, batteries, all of the maintenance logs, the training, all of those things, some may choose not to do that or not to want to do that and rely on a third-party provider for that. And that's, of course, what we've been modeled after, is taking what's been working alive well in the 135 fixed-wing world and apply those to the unmanned world to show that standardization and that commitment to safety.
Thanks, Will.
Yeah, and I know we're kind of up on our time here, so I'll keep it short and simple. An example I like to always give for kind of future state operations is, full system integration. So that's with your drone that's flying beyond visual line of sight, kind of a substation or a box in a substation, if you will, especially for our rural areas. That drone is in direct communication with our line sensors out in the field, our fault indicators and other systems and sensors that let us know when a problem arises. And then it'll tell the drone where to fly to, when to fly, and then it'll start collecting that data, send it back to a repository or run it through analytics, generate a report to send to a manager or supervisor that then issues the work to the guys before potentially they even show up to start picking out from stores or getting poles in place to get that restored. So kind of like Eric said, I think it's going to have a huge benefit on the reliability and restoration times, which and then in turn kind of help a lot in that efficiency and cost savings.
Absolutely.
And Mike, I want to take that just a step further, because when you start seeing other industries inside of the other verticals inside of the drone industry kind of merging that technology together, with the drones in a box in a substation, I think we'll also have delivery drones that are going to drop material and pick units out to location while the Tesla bucket truck swings by and picks the lineman up after hours. So I think you'll start seeing a lot of these different vertical technologies start merging together. And as the utilities adopt it, it'll definitely be something a sight to behold, if you will.
It certainly will. Thank you, gentlemen, for your great information today. Just wanted to say thank you also to Amanda and the team over at UASTI. And finally, to the people in the audience, we appreciate your attendance and your attention. I'm sure that you can get in touch with us if you need to. Amanda has our contact information. Our websites went out in the chat. That being said, it looks like it's a bright future for UAS and utilities. We're at time. Enjoy your lunch, and everybody have a great rest of your day.
Thanks, everyone.